Next speaker will be Dr. Ioana-Daniela Dulama, Scientific Director, Institute of Multidisciplinary Research for Science and Technology, Valahia University of Targoviste. She is from Romania. So she will talk on the ability of edible vegetables to accumulate toxic metals and the risks generated by their consumption to human health. Welcome, Dr. Dulama, please.
Hello, thank you for the introduction. I will share my screen. It's okay, you can see my presentation?
Yes, we can. Go on, please.
Okay, my name is Ioana-Daniela Dulama. I'm a scientific researcher on Valahia University of Targoviste. And my presentation is structured in introduction, a few indexes used for potential phytoremediation, another one for the health risk assessment, and some data obtained on edible vegetables. My presentation starts with the abstract based on the fact that in the last decades, food security became a high priority issue, as well as a new indicator for sustainable development at the global level. Some plants tend to accumulate one or more toxic metals. Also, their consumption disrupts the proper functioning of the human metabolism and can cause seriously disease, including cancer. Based on this, in my paper, I try to evaluate the accumulation and translocation indexes, as well as the health risk assessment, using the United States Environmental Protection Agency recommendation. For the phytoremediation potential of the plants are usually used two indexes, the accumulation index and the translocation index. First one, the accumulation index, is the indicator of metal transfer from soil to plants. This is very important for human health due to the fact that it can explain the risk of human exposure at contaminated soil. The translocation index represents the ability to plant to distribute different substances, including metals, from the roots across to the plant tissue. For the health risk assessment, the first indicator is named estimated daily intake and represents the estimation of the average of the metals ingested daily into the body system of a consumer. This indicator can be calculated as the metal content in the plant multiplied by the average adult daily intake rate. This is also reported by the World Health Organization for every vegetable, or for tea, this parameter is different from plant to plant. This estimated daily intake can be compared with the recommended daily intake or tolerable intake level. This can be extracted from the United States Environmental Protection Agency for every metal you want to calculate. For example, the first for recommended daily intake, we found data for chromium, manganese, copper, cadmium, but for nickel and lead, because they are very toxic, you find in the literature tolerable intake level. Based on the estimated daily intake, can be calculated another two indexes. The first one is carcinogenic risk. This parameter is used to estimate the probability to develop cancer as a consequence of exposure to lead and arsenic. For these indexes, you can use this formula, and the cancer slope factor, the CSF parameter, are given below. The daily intake metals is calculated to as average to this estimated daily intake reported at the body mass. For the adult, you can choose a value between 65 and 70 kilograms, but for children, you can use 14 kilograms. The next step to evaluate the health risk index, also known in literature as target hazard quotient, represent the evaluation of health risk induced by the consumption of contaminated food. For this parameter, you can use the daily intake metal calculated preview reported to the reference dose. For the vegetables, you should use the oral reference dose. These data you can find also in the literature and on the Environmental Protection Agency. The first study is based on Urtica dioica, also known as nettle. This was taken into account due to the fact that it's very known that it accumulates a high content of lead. We collect 10 needle samples and also 10 soil samples from several villages around Targoviste city. Here is our city, and with green point you can find the sample points. For the first step, we obtain the bioaccumulation factor, but for all elements and for all samples, we obtain values lower than 1. And we can say that these plants do not have a high capacity to transfer metals from soil to plant tissue. Also, we calculate the daily intake metals for an adult with a body mass of 65 kilograms, which consume daily 345 grams per day of Urtica dioica. In Romania is used in food in something like the spinach puree. In these plants, copper and zinc have high content, but they are essential elements. But if we consume a high quantity, copper and zinc become toxic. For the health risk index, calculated as we presented below, we observe that chromium, in fact, chromium, cobalt, copper, and cadmium and lead have values higher than 1, and this is a big problem for the health risk. And for nickel and zinc, we have values lower than 1. But if we take into account that total health risk index for our samples, the collected samples are very toxic for human health. Another study is named Heavy Metals Associated with Health Risk in Wild Edible Mushroom. In recent years, edible mushroom consumption has increased in the human diet, but also these vegetables accumulate high content of metals, of toxic metals. And for this study, we collect mushroom samples from 6 sites, 2 industrial cities, 3 touristic cities, situated at the limit of the Butej National Reservation and another site in the transition area. For the phytoremediation potential of these mushrooms, we evaluate the transfer factor and the translocation index for all samples and for 5 metals. The results regarding transfer factors show that Armillaria ramelea and Macrolepiota procera species accumulated high content of chromium in the entire breathing body, while translocation index value highlighted that all mushroom species have a significant capacity to translocate metals from site to cup. For the health risk index, we calculate the estimated daily intake and the carcinogenic risk associated with mushroom consumption. We do this evaluation on mushroom species and on collection site. In terms of carcinogenic risk, Armillaria ramelea species, including 2 samples from the 20 collected, is the most toxic mushrooms for human health, even for adults and for children, especially when it reaches maturity. And the data obtained for estimated daily intake revealed that all studied samples functioned as important source of copper and lead, both for adults and children.
Dr. Dulama, I'm really sorry to interrupt you.
1 minute.
Yeah, only 1 minute, yes.
1 minute, okay, thank you. For the health risk index, you can see on this chart that health risk index is have values higher than 1 for cadmium for both adults and children. In conclusion, all of us need to be careful about what kind of vegetables we eat so as to reduce the health risk. Thank you for your attention, and thank you for the organizer to inviting me.
Thank you very much, Dr. Dulama.